All right, so this is another video for section 5.2, and here are all the examples under example 3 in our notes. Now there's A through F, so what is that, 6 of them? Okay, so assuming you've watched the video for example 2 already, why don't you try to do A and B? So pause this and try to do A and B on your own, and then I'll work them out and we'll go over the answers. But try to do them on your own because you should be able to do them. All right, hopefully you've gone and done A and B on your own, so I just want to go over them. Here it is worked out. So all I did is I broke 135 down to the prime factorization, so I got 3 3s and a 5. Our power is 3 here, so we group them into 3s. The pairs come out front, leftovers go in the radical, so we just get the 3 here, and then the cubed root of what's left over, which is 5. Okay, so on B now, same thing, 500, I broke it down. And then once again, this is to the third root. So I grouped them into 3. So I had 3 5s. And then I had 2 leftover 2s, but they're not in a group of 3, so I can't use them. So when there's more than one, you multiply them. Okay, so 5 cubed root of 2 times 2, which is just 5 cubed root of 4. All right, let's look at part C now. All right, so let's look at C now. C is a little bit extensive, but it's doable. Okay, now we could change this into the 5th root of 7/8, right? But that does us no good. Okay, this doesn't simplify any, so we're not going to do that. That only complicates things. Okay, so we're going to leave it as the 5th root of 7 or the 5th root of 8. Okay, now, we need somehow to rationalize this denominator. Remember, back when we did square roots, we can't have a square root on bottom. Okay, so the easiest way to do this is to make this somehow 5th root of 8 to the 5th, because the 5th root of 8 to the 5th would just be 8. Okay, so in order to do that, I'm gonna, multiply this by the 5th root of 8 to the 4th. Okay, because we already have an 8 here. Okay, so if I multiply the bottom by that, I'd have to multiply the top by that too. Okay, so 5th root of 8 to the 4th over 5th root of 8 to the 4th is what I multiplied my original equation by. So what I get here is 5th root of 7 times 8 to the 4th over the 5th root of 8 times 8 to the 4th, which is, the bottom is 5th root of 8 to the 5th over 5th root of, let me check my calculator here, that is 28672. That's a big number. 28672. Okay. All right, so I'm going to kind of carry on down here. Okay, so we have on top 5th root of, we'll deal with that later, 28672 over the 5th root of 8 to the 5th, guys, that and that goes away, so that's just over 8. Okay, so the bottom looks good. Now all I have to deal with is the top. Okay, so 28672. All right, this is long and extensive, but it's doable. Okay, so this is a prime number, so we know that 2 goes into it. And if you divide this by 2, you get 14336. Okay, once again, we have an even number, so 2 goes into that. 7168 times. 2 goes into that. 3584 times. 2 goes into that. 1792 times. Okay, we're already getting quite a bit lower. 2 goes into that. 896. 2 goes into that. 448. 2 goes into that. 224 times. 2 goes into that. 112. 2 goes into 112. 56 times. 2 goes into 56 28 times. 2 goes into that 14 times, 2, 7, 7's prime, 1, we're done. That was a lot. Okay, so we want groups of 5, right? So 1, 2, 3, 4, 5. And do we have another 5? 1, 2, 3, 4, 5. We do. Awesome. Okay, so we have 2 groups of 5 2s. So out front will be 2 times 2. And then 5th root of 2 times 2 times 7. Okay, so I can simplify this. Remember, we just have the 8 on bottom. The top we have 2 times 2 is 4 times the 5th root of, what is that, 28? Okay, we're almost done. We have one last thing to do. Okay, notice 4 over 8 reduces to 1 over 2. So I could have 1/5 root of 28 over 2. Realistically, we don't need this one. So just 5th root of 28 over 2. That would be our final answer. All right, now that we've done C, I want you to go ahead, pause this video, try to do D on your own, because D is very, very similar to part C. So go ahead and pause this, try to do D, and then we'll go over it. All right, so this is what you should have gotten right here. Okay, so on the bottom we have 4th root of 4. So our goal is to get the 4th root of 4 to the 4th power. So to do that, we multiply by 4th root of 4 cubed. Okay, so if we take care of the bottom first all the way across, that would mean we get 4 over here. Okay, but if we multiply the bottom by the 4th root of 4 cubed, we have to multiply the top by the 4th root of 4 cubed. So then we can combine the 19 and the 4th root of 4 cubed to get the 4th root of 19 times 4 cubed, which is 1216. Okay, it's a big number, but it's doable. Not too bad, right? So we broke 1216 down with its prime factorization, and we got that it would equal 2 times the 4th root of 76, and then the 2 over 4 cancel. So we're left with 4, the 4th root of 76 over 2, and that should have been your final answer. All right, so let's go to E and F. Now, luckily for you, E and F are kind of the same type, so we'll do E, or I'll show you how to do E, and then I'll have you do F by yourself. So in order to get rid of a radical on bottom, now a lot of you will just want to multiply it by square root of 3 over square root of 3. Don't write this down because I'm going to end up erasing this. If we do that, the bottom we would get, would have to distribute that through, would get 5 square root of 3 plus square root of 3 times square root of 3 is just 3. Okay, so multiplying both top and bottom by square root of 3 isn't going to help solve our problem of having the radical on the bottom. Okay, so what we're actually going to do is we're going to multiply this by the denominator's conjugate. Okay, so conjugates are just like A plus B. The conjugate of A plus B would be A minus B. Okay, all we're going to do is change the sign between the two terms. Okay, so this is 5 plus square root of 3. So we're going to multiply it by the conjugate would be 5 minus square root of 3. Okay, and if we multiply the bottom by that, we have to also multiply the top by that. Okay, so what we get would be 1 times 5 minus square root of 3 on top over 5 plus square root of 3 and 5 minus square root of 3. Okay, some of you are like, that looks more disastrous. Well, give me a second, and it'll look better here in a minute. So if I want to work this out down low, I'm going to put it in the box. Okay, so we have 5 plus square root of 3 and 5 minus square root of 3. Okay, so 5 times 5 is 25. 5 times square root of 3 is 5 square root of 3. 5 times negative square root of 3 is minus 5 square root of 3. And negative square root of 3 times a positive square root of 3. So I'm going to write this out over here. Would just be negative square root of 3 squared. Okay, which is square root and the squared cancel, which is just negative 3. So I'm going to put my negative 3 in here. Okay, now remember, to get the final answer when you multiply these together, you just add each of these boxes. Well, the great thing about a conjugate is if we look here, we have 5 plus square root of 3 and minus 5 square root of 3. So those basically cancel each other out. So I'm left with 25 minus 3, which is just a 22. Okay, so the denominator here is 22. That's beautiful. Okay, and then 5 minus square root of 3 is on top. That is our final answer. All right, go ahead and try to do F. It is very, very, very similar to E, and then we'll go over it. All right, so for example 3, this is what you should have gotten. You should have multiplied it by a conjugate, which is square root of 7 plus 2. Okay, so when you do that, you get 2 square root of 7 plus 4 on top. And then when you FOIL all this out, or if you put it in the box, whatever, and multiply it together, you will get 7 minus 4, which is just a 3. Okay, so this or this would be fine. Okay, either one of those would be sufficient.